Okay, welcome everyone. We will start operation with numbers, and let's start the classifying the numbers, such as we have different type of numbers. The first one is whole numbers. You all know from the primary school, and the whole numbers decide the whole things like 1 apple, 2 apple, 3 apple, 4, and we can call them counting number 2. Natural numbers, the difference is natural numbers we start with 0. So 0, 1, 2, 3, 4, they are called natural numbers. And after that we have integers, and integers opposite of the natural numbers, so we call it negative side, -1, -2, -3, so it's continue. 1, 2, 3, 4, and the 0 at the middle, so we call this type of numbers integers. They're whole, but they have a negative sign and a positive sign. Rational numbers, the rational numbers are numbers that can be written a over b, so such as oops, sorry, I couldn't choose the correct pen. Such as 3 over 5. 3 over 5, it's a fraction, and 3 over 5 as a rational number. Or 1.2, it's equal, let me say, 6 over 5. So it's again, how it's 6 over 5? 12 over 10, it's going to be equal 6 over 5. So we can write as a fraction. We call this type of fraction rational numbers. Of course, I can write 5 equal 5 over 1. Oops, sorry, let's write it correctly. 5 over 1. So 5 is rational number 2. All these numbers are rational. Near them we have fractions. All fractions are rational numbers and decimals, but there are some problem with the decimals. Why? Let's read the irrational numbers. Irrational numbers whose decimal part does not terminate. Terminate means has end, and does not terminate, that means continue forever, and not repeating. So does not terminate or repeat. So let's put the parentheses here. Not terminate or not repeat. Such as what? Let's say 5.3333. It's repeating decimals. If you continue it, we call it 5. 3 repeating, so we can write it 5 whole and 1 over 9. So we can write it decimal, it's gonna be 46 over 9. 9 times 5, 45, plus 1, 46 over 9. When it's repeating decimal, there is a way to write it as a fraction. But if it's not repeating, such as 5.1211211221113 11133, so that's not gonna repeat if I continue with the same pattern. So we will call it not terminating because it's continue forever and not repeating. There is no repeating part, and we call this type of numbers irrational numbers. Usually when we say irrational numbers, square root numbers 3, like square root of 3, if it's not a perfect square, square root of 5, or the pi, that's an important irrational number. These numbers called irrational numbers. You have to understand, if it's repeating, and not terminating, we call them irrational numbers. Real numbers, all the numbers, rationals and irrationals together, we call them real numbers. Okay, let's come to a question. Classify each numbers with an explanation. 2.35. You can write that one equal 235 over 100. So what is it? It's no answer. Let's check back. It's an rational number. Why? We can write as a fraction. So rational. Negative 0.35. You can write it as a negative 35 over 100. So still I can write it as a fraction. Again, rational. Rational. Sorry about my handwritten. Okay, 78787878, and it's not terminating. It's continue, not with, and it's repeating. So we can write that one 5.78. And when it's repeating decimal, we can write as a fraction, and we will call this rational. Look at that one. 1 2 1 1 2 2 1 1 1 2 2 2 1. There is no repeating. 1 2 1 1 2 2 1 1 1 2 2 2 1 1 1 1 1. That's gonna not, there is no repeating pattern. Here, as you see, 7 8 7 8 7 8 7 8 repeat. There is no repeating pattern. So if there is no repeating pattern, we are gonna say this is irrational. That's an irrational. It's been a long time I didn't use the tablet, so sorry about my handwritten. Okay, let's continue. Represent the following numbers on the number line. So you have to know the number line. Let's draw a number line. Okay, let's put the 0 at the middle. And this is 2 whole 1 over 3. 1, 2. 2 whole, but it's more than 2 whole. We have 1/3. So between 2 and 3, I can cut it 3 equal part. And 1 over 3. 1, 2, 3, but it's gone to 1 over 3. So this one, 2 whole and 1 over 3. That's half. Bigger than 0, less than 1, half. You can cut 2 equal part and 1 over 3 at the middle. Negative 2 over 3. It must be less than 0, but more than minus 1. So how many part? 3 equal part. 1, 2. Why I put 2 line? Because I have 3 equal part. Now negative 2 over 3 from 0, negative 1, negative 2, here negative 2 over 3. So that's so easy. You cut 3 equal part between 0 and minus 1. And from 0 to the minus 1, we count 1, 2 part. It's called negative 2 over 3. Negative 3 whole 4 over 5, minus 1, minus 2, minus 3. But I need to more than minus 3 because I have more 4 over 5 after negative minus 3. Let's say here, negative 4. I need to cut between negative 3 and negative 4, 5 equal part. 1, 2, 3, 4. If I draw 4 line, 1, 2, 3, 4, 5 equal part. How many of them I need to move? 4. 1 over 4, 2 over 4, 3 over 4, no, 1 over 5. I cut it 5 part, sorry. 1 over 5, 2 over 5, 3 over 5. And that line is negative 3. That's the whole part. And 4 over 5. This is negative 4. Oh, sorry. That's negative 4 for this line. Don't confuse with it. Okay, that's all. You negative 3.7. Let's draw a new number line because I think that's enough example on one line. Put it here a little back. Okay. If you draw the number line, let's say this is minus 3, this is minus 4. You need to cut 10 equal part. So 5 gonna be at the middle. 6, 7. This is gonna be negative 3.7. Why 10 equal part? When we write decimal, it's exactly equal 3 whole and 7 over 10. When we write the decimal, the denominator get the 10. So we need to cut here 10 equal part between negative 3 and negative 4. And what about 1.5? 0, 1, 2, 1 and half. At the middle, between 1 and 2, this is going to be 1.5. That's very easy. I think you can do that. Oh, that's a good question. How do you represent square root 2 on a number line? As we know, square root of 2 is irrational number. So we cannot write as a fraction. If we cannot write as a fraction, how can I calculate it? Let's say this is 0. This is 1. How can I know square root 2? That's a tricky question. Now come to 1. Let's change the color of the pen. That's 1 unit. If I go 1 unit up with a rectangle triangle, let's say this is 1 unit. Here 1 unit. And this is 1 unit. Okay. That's gonna be isosceles right triangle. And there's an hypotenuse. Hypotenuse square equal 1. This is 1 square plus that's another 1 square. So c square equal 1 plus 1. C square equal 2. C equals square root of 2 because you need to get square root of to cancel that one. Of course, it cannot be negative because the distance, we are talking about distance. So the length of this line is square root of 2. When you flip this line, when you rotate this line on the origin, and this point, we are not exactly sure, but the length of this line will fall down here, and this is gonna be square root of 2. I think that's in it. So the length of the hypotenuse is square root of 2. So you can only rotate around it. That's gonna be square root of 2 on here. Take this one and rotate it. That's all. Okay. What about square root of 5? You can use the same method for square root of 5. This is 0, this is 1, this is 2. If you use the same method, and this is gonna be 2 unit, go up 1 unit, so hypotenuse 2 square plus 1 square equal hypotenuse square. Hypotenuse equal 4 plus 1, c squared equal 5. C equals square root of 5. So the length of this line is square root of 5, and it's gonna be some place here. If you rotate it, it's gonna fall some place here. So that's called, this is square root of 5. You can show that method using net method to the irrational number or root number that we can call. Okay, let's continue. Properties of addition and multiplication. So what we know? We know from the 7th grade commutative property, so you can change number place. 2 plus 3 equal 3 plus 2 plus 3 equal 3 plus 2. It doesn't change. That much you know. What about associative property? A plus B plus C, you can put the parentheses between A, B, so you can add A, B first, or you can add B, C first. It doesn't affect the result. Identity of 0 and 1, when it's addition, adding by 0 doesn't affect the number. So any number plus the 0, it's gonna be the numbers itself. Or any number multiplied by 1, it doesn't change the number. So we call it identity element, identity of 0 or 1 when it's addition, 0 when it's multiplication, 1. Opposite or inverse, if you know 5 plus minus 5, any number plus opposite of it equals 0. And when it's multiplication, any number multiplied by reciprocal of it. What is the reciprocal? If you write 5 and reciprocal of 5, 1 over 5. When you multiply them, that's gonna be 1. So that's inverse or opposite. When it's multiplication, inverse. When it's addition, we call it opposite. Distributive property, you multiply expand the brackets. You can expand the brackets by multiplication. The number and each number inside the parentheses, you can multiply one by one. These are properties. Lots of them you know from the 7th grade. Why we need that one? Of course, order of operation, and we use these properties algebra very much. When we learn algebra, we use it very much. What is the order of operation? Parentheses first. If we have exponent, then exponent. After that, multiplication and division, but from left to right, you need to solve them. Which one is come first? If the division on the left side, you need to solve the division. Subtraction and addition, or addition or subtraction from left to right. This is the idea how we solve them. Now evaluate the expression using the order of operation. Let's see. That's the numerator, that's the denominator. So we can solve them numerator and denominator together. How? First we can solve the numerator. 2 square. There is a parenthesis. Minus 1 minus 2 is negative 3. 2 square. And now this is negative 3 cube. Over 5 minus 3. That's another term. And I can calculate it. It doesn't affect the result. 5 minus 3 is 2. Let's continue. 2 square is 4. Negative 3 cube is minus 27 over 2. And I can simplify here, if you know basic mathematics, 4 divided by 2, 2, then this is gonna be 1. It's equal 2 times negative 27, negative 54. Order of operation, you can do it step by step, but you can simplify it here. It will make the question so easier. Let's change the color, but it looks like X. We simplify that one by that one. Okay, classify each number, and if there is a square root of and there is no perfect square inside the square root, we call it irrational. That's rational because it's a fraction. That's a repeating number, so rational. I told you pi is an important irrational number. Square root of 36, that's 36 is a what? It's a perfect square number, so it's gonna be 6 over 2, it's gonna be 3. And what we know about 3, it's a whole number. It's an integer. It's a rational number. It's a real number. Actually, all of them are real number. And if you remember, a real number, rationals and irrational. 9 over 3, it's equal 3. So they have same answer, I think. 6 over 2 is 3. And we can write all these for that one. 15 over 7, rational. 15 over 2, sorry, not 7. 15 over 2. 1, 2, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 1, 1, 2. This doesn't repeat. It cannot repeat that way. There's no repeating. It's not terminating. It's continue forever. It doesn't finish. So it's not terminating. Terminate mean end, not terminating, continue. Doesn't have end, but no repeating. So we will call irrational. Irrational. That's all for you. Sorry about my handwritten. Graph each number on the number line. We saw some example about that part. I think for this video that's enough. I will check some question if there are any difference. Okay, that's difference question. Expand this simple expand. So expand, that means we need to use distributive property. Simplify, if there are like terms we will add them. Justify, so if it's possible we will calculate. 2 times a, 2a, that's the expand brackets, that's the distributive property 2b. Okay, like terms, minus 3 plus 3 gonna be 0 because they're opposite, they have same value. 3a, 3a, minus n plus, they will get 0. Okay, let's that one. 8 plus 2, 10. 3 times 10 over 2. We can simplify 10 and 2, that's gonna be 5, that's gonna be 1. 3 times 5, 15. 15 over 1 gonna be 15. We don't need to write this one in the denominator. Let's see the other questions. If there are different questions, I will solve. Okay, order of operation, it doesn't take much time. My 1 minus 7 is minus 6 over 2 minus 5 is minus 3. That's gonna be negative divided by negative, positive. 6 divided by 3, 2. 4 times 5, you can directly cancel this 4. 4 divided by 4 because that's not the addition. The result gonna be 5. Let's try. 4 times 5, 20. 1 over 4 multiply by 20. Right here 1. 20 divided by 4, settle 5, so you can simplify. If this is multiplication, if it's not addition, we cannot. So here, only you need to multiply the coefficient and this one because that's an variable. We cannot do anything about it. Minus 20y squared because minus 5 times 4 equal negative 20. That's a good question. Evaluate each expression in order of operation question. Okay, what was it? Division and multiplication together. So we need to solve from left to right. 16 divided by 2 come first. This is 8. Multiply by 6 minus 1. Don't forget, you need to write this part after do operation. This is 8. So multiply by 6 minus 1. 8 times 6, 48 minus 1. 48 minus 1, I hope you know this much. 47. Again, be careful, here is a parenthesis. So inside the parenthesis, 6 divided by 3. Let me give you a tip. If we separate the terms in algebraic expression by positive and negative sign, plus and minus, we can do it for the order of operation. So I can do this 6 over 3 at the moment. What is 6 over 3? 6 over 3 is 2. So here I can write 2 minus. 10 minus 3 is 7 squared. Now, what is 7 squared? 2 minus 49. What is 2 minus 41? 49, negative 47. Order of operation again. I think these are the same problems. State the property. As you see, this is what we call it, commutative property. That's commutative property. That's commutative associative. I forget that's name. Sorry, let's check. That's how you study. If you forget something, you check it. What was it? Associative property. Yeah, that's one. Oh, its name. I forget its name. I'm very sorry. When the parentheses change, the result doesn't change. It doesn't affect what we call associative. This is commutative. This is the rule of zero, identity. Identity of zero, that's 1, sorry. 1 because it's multiplication. No, that's not identity. Sorry. That's not identity. I didn't pay attention. That's and that they are reciprocal each other. When you multiply it, we get 1. What is it? Reverse. Inverse or? I'm not sure. Let's check. If you forget something, you need to check it. Let's see. Inverse operation. Inverse, yeah. We don't say reverse. Reverse taking back. Reverse, you need to take it back. Inverse. Not reverse. Inverse. Let's put here. In, not re. Inverse operation. The opposite operation, you can call. And this is opposites. Opposite. I'm sure that's an opposite value. -7 plus 7 is opposite. Let's go and check it. Opposite, yeah. When it's addition and subtraction, we opposite. But when it's come to the multiplication, we call it inverse. Did I go very fast? Did I skip something? Yeah, I think so. And that's identity. When you multiply by 1, that's identity. Here, as you see, this distributive, expanding brackets, distributive. Again, commutative, the parentheses. Oh, that's, we can call that one associative because there is 2 multiplication. Because their places change, commutative. But when you change the place of the parentheses, that's we call associative. Here, a plus 2 minus 2 minus x. Oh, they change their places. As you see, together they change that one and that one. When we change that one and that one, that called commutative. When you change places, it's commutative, yeah. This is inverse. Inverse, yeah. As you see, reciprocal of the first one. They flip the value, the places. That's opposite. And this is identity element. Identity. Okay, that one, distributive property. 2 times 3 is 6. 2 times minus x minus 2x. So this is distributive property. I think that much question is enough for this video. I don't want to take lots of your time. There are a few questions left, but that's enough. I hope it will help you a little. I hope the next video will be better. Thank you for